Welcome back to Gyan Byte. Your app has a feature fetch a URL. Maybe it's an image preview, a webhook, or a PDF generator. The user gives it a URL and your server fetches it. But the user didn't give you a public URL, they gave you an internal one. And your server just fetched it. That's SSRF. Server-side request forgery entered the OWASP top 10 in 2021. It's behind the Capital One breach, 100 million customer records stolen through one SSRF vulnerability in a WAF. We'll see how it works, look at the cloud metadata attack that hit Capital One, walk through internal network pivoting, and cover the defenses. All practical. Let's go. Here's how SSRF works. Your app has a feature that takes a URL and fetches it server-side. Normal use, user gives a public URL, maybe an image for a profile picture, a webhook callback, or a link preview. Your server fetches it and returns the result. The attack, instead of a public URL, the attacker gives your server an internal address 169.254.169.254. That's the cloud metadata endpoint, or 10.0.0.1, an internal service. Your server fetches it because it has network access the attacker doesn't. The server becomes the attacker's proxy into your internal network. SSRF turns your own server into a proxy. The attacker can't reach internal services, but your server can. SSRF isn't theoretical. It caused one of the biggest data breaches in banking history. 2019, Capital One, a former AWS employee, found an SSRF vulnerability in Capital One's web application firewall. She used it to reach the AWS metadata endpoint 169.254.169.254. That endpoint returned temporary AWS credentials. With those credentials, she accessed S3 buckets containing 100 million credit card applications, 140,000 social security numbers, and 80,000 bank account numbers. One SSRF request, 100 million records. 2021. GitLab SSRF vulnerability in their webhook feature allowed attackers to scan internal networks and access internal services. GitLab rated it critical, CVSS 9.9. 2020. Shopify bug bounty researchers found SSRF in the image upload feature. It could access Google Cloud metadata and steal service account tokens. Shopify paid $25,000 for the report. The cloud metadata attack. This is exactly how Capital One was breached. Step 1. The attacker finds a feature that fetches URLs, a webhook, an image previewer, a PDF generator. Anything that takes a URL and makes a server-side HTTP request. Step 2. Instead of a normal URL, they send this HTTP 169.254.169.254/latest/metadata. That's the cloud metadata endpoint. Every AWS, GCP, and Azure instance can reach it. It's a local link address only accessible from inside the cloud. Step 3. The metadata endpoint returns temporary credentials, AWS access keys, session tokens, IAM role information. These credentials let the attacker access S3 buckets, databases, anything that IAM role has permission to touch. Step 4. The attacker uses those credentials from their own machine. They list S3 buckets. They download everything, 100 million records, game over. One URL, cloud metadata, temporary credentials, full cloud account access. This is the Capital One attack. Cloud metadata isn't the only target. SSRF lets attackers pivot through your entire internal network. Your server sits inside a private network. It can reach databases, admin panels, internal APIs, monitoring dashboards, services that are never exposed to the internet. The attacker uses SSRF to scan your internal network. They try 10.0.1, 10.0.2, and so on. Different ports. HTTP responses tell them what's running. They are mapping your infrastructure from the outside through your server. Common targets: Redis on port 6379, no auth by default, Elasticsearch on 9200, query any index. Internal admin panels on port 8080, often no authentication when accessed from inside the network. SSRF turns your server into a port scanner and proxy. Every internal service your server can reach, the attacker can reach too. You might think, just block 169.254 and 10.0.0. Attackers have bypass tricks for that. DNS rebinding. The attacker registers a domain that resolves to a public IP first, passes your URL validation, then switches the DNS to resolve to 169.254. Your server's second request hits the metadata endpoint. URL encoding tricks. Instead of 169.254, they use the decimal form, or the hex, or the IPv6 mapped form. Same destination, different format. Your blocklist doesn't catch it. Open redirects. The attacker sends a URL to a public site that redirects, and the redirect target is the internal address. Your server follows the redirect and fetches the internal resource. Blocklists alone don't work. Attackers encode, redirect, and rewind their way past string-based URL checks. How do you stop SSRF? There are 4 defenses, and you need them all. Defense 1. Allowlist, not blocklist. Don't try to block bad URLs. Instead, define exactly which domains and IP ranges your server is allowed to fetch. If it's not on the list, reject it. Defense 2. Use IMD SV2. AWS's Metadata Service version 2 requires a PUT request with a special header to get a token first. SSRF via GET requests can't reach it. GCP requires the metadata flavor header. Enable these. Defense 3. Network segmentation. Your web server should not have direct access to databases, admin panels, or metadata endpoints. Use VPC security groups and firewall rules to limit what your server can reach. Defense 4. Resolve and validate. Before making the request, resolve the DNS to an IP address. Check the IP against your allow list. Then make the request using the resolved IP, not the hostname. This stops DNS rebinding. Allowlist destinations. Use IMD SV2. Segment your network. Resolve before fetching. Defense in depth stops SSRF. 6 concepts. 1 URL input. What is SSRF? Your server fetches attacker-controlled URLs. Real breaches, Capital One, GitLab, Shopify, Cloud Metadata. 1 URL steals AWS credentials, internal pivoting, scan and access internal services. Bypass tricks, DNS rebinding, encoding, redirects. And defenses: Allowlists, IMD, SV2, network segmentation, resolve before fetching. The rules: Allowlist destinations, enable IMD, SV2, segment your network, resolve DNS before fetching, defense in depth. If you found this useful, like, subscribe, and stay secure. See you in the next one.